Problem 35 reads, so this is crossing the river number 1. A river flows due south with a speed of 2 meters per second, as drawn here with the arrow. You steer a motorboat across the river. Your velocity relative to the water is 4.2 meters a second due east. Here's our north arrow for relative directions. The river is 500 meters wide. So we need to find A, what is the velocity, the magnitude, and the direction relative to the Earth. To do that, it's pretty simple. We have an x component and a y component of our velocity, so we can use Pythagorean theorem, or just taking the norm, which is the exact same thing. So our velocity will equal the square root of our x component, 4.2 meters per second squared, plus our y component, 2 meters per second squared, which will equal 4.65 meters per second. For the direction, I decided to use angles. So using you can take the inverse tangent of our opposite, which based off of our angle is 2. Oh, I messed up a little bit. 2 divided by 4.2. So the inverse tangent of 2 over 4.2 is 25.5. When in reality, so that is so many degrees. So that is going east, so many degrees to the south. So to get south degrees to the east, we take 90 minus 25.5. So we are traveling south 64.5 degrees to the east. Next is for part B, where did I set this? Right here, is how much time is required to cross the river. So we just need to figure cross. It's 500 meters across. So R will equal our Vx times T. So 500 divided by 4.2, our Vx will equal our time, which is 119 seconds. So now we have the time, and for part C, we need to figure out how far south we are from the starting point once we cross the river. So our y, which is how far south we are, will equal our y component times t. Our y component's 2. Our time is 119 seconds, so we're 238 meters south of our starting position when we finish crossing.